Okay, overview of this one. This is on species concepts. So it turns out people are always saying like, oh, okay, I believe that, evolution can happen within a species, but I'm not sure how they can change species. Well, to answer that question, can we really change species? We have to define a species, and it turns out there's lots of ways to define a species, and scientists don't agree. And so that makes that whole change in kinds that you see people debating over in the creationist movement is really hard to define, turns out, scientifically. And so I've walked you through several of the species concepts. Usually we use them all together so that we kind of get the best idea of what a species is. So I've given you these orchids, and it really doesn't matter how many species there are there. But some of the things, the first one is morphological, right? And it talks about the pros and cons of each of these, but I'm just going to show you the data and then we'll talk about them. So in morphology, we're using the actual physical characteristics of the organism to decide if they're the same species or not. So in this case, we were looking at flower size, right? But the pros of this is it's really easy, and we can use it on things that are dead, right? Things that are fossils. We can use the morphological species concept. But it becomes tricky when we have things that maybe change their morphology during their lifetime, like a frog, right? Or where there's sexual dimorphism, extreme sexual dimorphism. If you looked at a black widow mama versus a black widow daddy, they don't look the same at all. You might classify them as different species. So we don't totally rely on morphology. Plus, you've got convergent evolution, right, where they converge on the same feature, but it's not necessarily because they're related. And so we have to be careful with the morphological species concept. But sometimes it's the only one we have. We're looking at dinosaur skeletons. What are we going to do? Morphology is about all we have. The second species concept is the biological species concept, because we're looking at pollinators, so allowing the species to mate. Okay, and so the biological species concept says that if they can mate and produce viable and fertile offspring, then they are different, or then they're the same species. And if they can't, then they're not the same species. Well, this is great in that it's very clearly defined as far as if babies pop out and they're alive. But it can be really tricky in cases where you can't really mate them, like they never come into contact with each other, but they could mate if they did, or they mate in captivity but not in the wild, or they mate and their offspring are usually sterile but not always, like a mule. They're not always sterile, and so it becomes a little bit of a mushy topic if you really look at it. But it's one that's the most commonly used, and we'll talk about how things get isolated. I think it's in a minute. This one, looking at DNA, so this is probably the most reliable as far as there's no ambiguity in whether it's an A, a T, a C, or a G, right? And we build these phylogenetic trees, which we'll practice doing next week, so don't worry too much about those. But when we're looking at sequences, this is a good indication of relatedness. The problem becomes deciding how different does it have to be in order for us to decide it's a different species and not just a random mutation that happened in one of the organisms. And so that's actively debated in the scientific field. That's phylogenetic species concept. And the last one is ecological species concept. So we look at where they live and what resources they use, what niche they fill. And this is a helpful one for things, again, that we can't necessarily make them mate, or we don't have access to them, or we're looking at some fossilized species and just looking at what their distribution was. Problem becomes, again, if some of them will change their ecological niche throughout their lifetime, like a frog, again, they live in the water sometimes and in more of a terrestrial aquatic lifestyle at other times. And then also it becomes difficult if, you have sometimes they'll fill this niche, but if there's a competitor in the area, they fill a different niche. And so they're not a different species just because there's a competitor in the area. And so this can become complicated too. And so the point is we have to use all of these sort of together. Now I want to roll down to the biological species concept, some of these things that might separate them. And so we've got prezygotic, so before the sperm and egg come together. And those are things like behavioral, they do the wrong mating dance, or temporal, they come into heat at different times of year, so they never actually breed. Habitat isolation, like a tiger and a lion, they can reproduce, but they live on different continents, and so they rarely do reproduce. And then gametic isolation is where there's actual incompatibility with the egg and the sperm, and mechanical meaning they can't even get the sperm to the egg, like physiologically they can't mate. And then you have post-zygotic barriers where the babies are either they die before they really are born or shortly thereafter, or they're sterile. So for example, I used to raise birds and I had pigeons and doves in the same cage, and I thought they were different species, but they didn't have a prezygotic barrier. They had a postzygotic barrier. And so this baby was born, and it was like this full-blown Frankenstein mutant. It had a leg poking up between its two wings on its back. It was crazy, and it died within just a couple days. So it had hybrid inviability. And so they were different species. Needless to say, I separated them. Okay, so those are your species concepts. And then, sorry, I'm kind of scrolling fast. And then we look at ways of speciation. So the Grand Canyon squirrels, obviously a canyon formed in between their populations. And then over time, just genetic drift caused them to drift apart enough that they don't come into contact with each other anymore. And so when we have an actual physical barrier, we call it allopatric speciation, where they have a physical barrier that separates them. Whereas the hawthorn and apple maggot flies, they have this issue where they just sort of picked a fruit, and then over time, the fruit that comes into season first, they come into season at different times, and so the apple flies are hatching out and doing all their mating before the hawthorn flies even come about, or it might be the other way around, I can't remember. But they come into heat at different times, so it's actually a temporal isolation, but they're still coming into contact with each other. And so we would call that sympatric speciation. Sim meaning they're still together, but they seem to be not interbreeding anymore. And so those are the two speciation events. So we'll talk a little bit more about how speciation occurs in class, but that's the gist of this assignment.